Welcome to today's video. We will dive into the world of indefinite integrals and one of the most essential techniques in calculus, the use substitution. Whether you are just getting started or looking to strengthen your understanding, this video will guide you step by step through solving integrals by substitution, showing you how we turn complex expressions into manageable solutions. So grab your notes and let us unravel the magic of integration together. Now, looking at the indefinite integrals, as we did before, we got to see that whenever you have an integral sign over here with no upper and lower limit, that is when we call the integral indefinite. Now, in this case, in solving these type of questions, what we use is the substitution method, or we sometimes call it the use sub method. Now, in this case, choosing your u is very critical to solving the problem. Now, let's solve this question. In solving this question, we have this expression right here and this expression right here. So the question is, which one do we select as our u? Now, to help you select your u, most of the times whenever you have an expression with an exponent, your u is most of the times that expression. So in this case, let's select u to be equal to x cubed plus x. Now, if u is equal to this, you find your du dx. And now if we differentiate the expression, you have 3x squared plus 1. Notice that we have the x over here, so we can also make the x the subject in this expression that we have here. In that case, if we make the x the subject, we are going to get du to be equal to, we have 3x squared plus 1 dx, because if you cross multiply these two, you have that. And if you want to make the x the subject, you get the x to be equal to du over 3x squared plus 1. Because if you divide both sides by this is what you get. Okay, so since we've been able to do that, let's rewrite our expression. Now we are going to get the integral. This whole thing was u, so we have u to the exponent of 5. And now we have 3x squared plus 1. And now the x is now giving us this right here. So we have the u out of 3x squared plus 1. Notice that this right here cancels out this. So in other words, what we have is the integral of u exponent 5 du. Okay, so if you are integrating a polynomial expression, remember, you always add 1 to the exponent and you divide by it. Then afterwards, since this is an indefinite integral, you have to add your c. But our u was given to be x cubed plus x. So we have x cubed plus x all to the exponent of 6 out of 6 plus c. And this is your answer for the question. Now, the reason why this was able to, this u was able to satisfy this problem was because we were able to do some cancellation right here. Now, let's see, what if we selected u to be 3x squared plus 1? If we did that, we would have gotten the u dx to be equal to 6x, right? And we are going to have the x to be equal to du over 6x. Let's go back to see if we are going to have anything to cancel out. In that case, you are going to have integral of x cubed plus x to the exponent of 5. Now, 3x squared plus 1 is u, and the x is just du over 6x. Notice that this 6x does not cancel out any term over here. In that case, the question becomes very difficult to solve. So this approach does not work, right? So you can't use this. So sometimes you can just try and testing to see if the u that you picked will work. Let's look at a second question. Let's say you have this. You have to find the integral of 2x plus 1 dx. In this case, whenever you have a square root expression, always let what is inside the square root be your u. So we have u equal to 2x plus 1. Now if we differentiate u with respect to x, we are going to have positive 2. And to find the x is just the u out of 2. So now let's rewrite our expression. We have the integral square root. Now 2x plus 1 is now our u, and the x is now the u out of 2. After doing this, we can rewrite this expression. Since 1 over 2 is a constant, we can bring it outside and we have our integral. But note that root 2 is the same as u exponent 1 over 2. So we are going to have 1 over 2, and if we integrate, remember we add 1 to the exponent and we divide by that result. So if we add 1 to 1/2, we are going to get 3 out of 2, and we divide by 3 out of 2. So simplifying this, 1 over 2 over here dividing 3 out of 2, that will just give you 1 out of 3, and you have u to the exponent of 3 out of 2. Since it is indefinite, you have to add your plus c. But notice that u was 2x plus 1, so you have to do your substitution. So in this case, you have 2x plus 1, then to the exponent of 3 over 2 plus c. And this will be your answer. Okay, let's look at a different question. We have another question where we have the integral of secant squared 5x plus 1 and 5 dx. Now we have to integrate this expression. Which one do we select as our u? Now in this case, you see what is inside the parenthesis becomes your u. So you have 5x plus 1. If you differentiate u with respect to x, you have positive 5. So if you want to find the x is just u out of 5. Now in this case, going back to rewrite the expression, we are going to have secant squared. Now 5x plus 1 over here is giving us u. So we have secant squared of u multiplying 5 multiplying the x. But we know the x to be equal to the u out of 5. So clearly you get to see that these two terms over here cancels out. So we are going to have the integral of secant squared u du left. So how do we integrate this? What is the integral of secant squared du? Or in other terms, what do you even differentiate to get secant squared? Now remember, if we differentiate tan of x, you get secant squared x. So in this case, we have the tan of u. And since it is indefinite, you add your plus c. Now you have to do your substitution. Your u was giving us 5x plus 1, then plus c. And this will be your answer. Okay, let's look at a different one. We have cosine of x e to the exponent of sine of x dx. Remember, I told you that whenever you have an exponential expression, your exponent becomes your u. So in that case, we have u to be equal to sine of x. And if you differentiate this with respect to x, you have cosine of x. Then you make the x the subject in this expression. If you do that, you have the u over cosine of x. Then you rewrite the expression. So you have cosine of x, then e to the exponent of sine x, which is now u. Now the x is just the u out of cosine of x. So clearly these two terms over here cancels out each other. So you just have the integral of e to the u du. And remember, if you integrate e to the exponent of u, you have the same thing plus your c. But note that u is just sine x, so you just have e to the exponent of sine x plus c. Now, what if we chose u to be equal to cosine of x? Would that work? Let's try it out. Remember, if you differentiate this, you have negative sign of x. So your dx is just negative du over sine of x. So in rewriting the expression, we would have gotten e to the, we would have gotten over here this to be u multiplying e to the sine of x multiplying, we can bring the negative here, we have du over sine x. Notice that this sine x over here cannot cancel this sine x because it is an exponent, right? So this becomes very complicated to solve, and the substitution method does not work. So you can't use this approach. That's why I'm saying that you can also do try and luck, right? So if you do cos x and it doesn't work, then you can also choose your sine of x as well. Okay, now let's look at the last question. For the last question, we have the integral of x sine of x all squared out of the integral of 1 minus s squared dx. Now, having this question, you have to ask yourself, we have square root of 1 minus s squared and we have x sine x. By immediately seeing this question clearly, I can see which one to choose as my u, because I know that if I differentiate x sine, I'm going to get a term with square root of 1 minus squared in it, right? Remember, in this case, if I select u to be x sine of x, right? If I differentiate u with respect to x, remember if we differentiate x sine, you have 1 over 1 minus s squared. So if you want the x is just du is just this 1 minus square root of s squared du. Because if you cross multiply, 1 times dx will give you dx, and this times this will give you this right here. Okay, so now we can go ahead to do our substitution. We are going to have u squared in the numerator. In the denominator, we have 1 minus s squared. Now the x is giving us 1 minus s squared du. So you get to see that these two terms cancels out each other. And in that way, you are just going to have integral of u squared du. So it becomes very simple to solve. Now this is just u cubed out of 3 plus your c, and you know your u to be, so you can have 1 over 3 u, as we know, is just arc sine of x, then cubed, then plus your c, right? So this is easy. Now let's say you didn't know that arc sine, if the differential of arc sine will contain a term of square root of 1 minus s squared, and you chose your u to be say 1 minus s squared, right? Doing the same thing, if you differentiate the u dx, this will just be minus 2x right here, and you're going to end up getting the x to be equal to minus the u out of 2x. In that case, if you are doing your if you are rewriting the expression, you're going to have arc sine x all squared out of, say, square root of u times you have minus du out of 2x. So you see there is no term to cancel out, and it's become very difficult to solve this problem. So as always, you can just try and test, and whichever process that works for you, that will do. So that is it for today's journey into indefinite integrals and u substitution. I hope this video clarified the method and gave you confidence to tackle similar problems on your own. If you found this helpful, don't forget to like, share, and subscribe for more math content. Leave a comment below with any questions or topics you would like to see next. Thanks for watching, and as always, keep learning and stay curious. Bye.